Welcome to The Explainer. Today, we're diving into what happens when a wildly creative piece of human imagination just smashes head-on into the strict rules of astrophysics. Sometimes asking questions from a purely artistic, creative standpoint actually opens up these incredible, mind-bending scientific realities. We're going to explore a concept today that started with just a really poetic phrase, and it literally led us straight into the deepest mysteries of dark matter, bent light, and the actual fabric of space-time itself. Because as we'll see, the way our universe actually works, it's often way more bizarre than anything we could just invent.
Okay, let's jump right into section 1, a sequin universe.
A sequin universe. What an incredibly poetic prompt, right? That is our starting line today. Think about it. What does a sequin actually do? It catches the light, it reflects it, it bends it, and it gives off that beautiful sparkle against a dark background. So applying this idea of a glittering, light-manipulating universe to the actual cosmos, well, it's just a fantastic conceptual starting point. And honestly, physicists absolutely love looking for exactly this kind of creative symmetry. They're always out there actively searching for mirrors and balances and these almost poetic opposites when they're trying to decode nature. Now, this whole sequin idea translates into a really specific, totally fascinating hypothesis. What if we treat dark matter as reverse light? Just imagine it. If the universe is completely packed with massive amounts of invisible dark matter, maybe that dark matter is just, an opposite light that actively bends the normal light we can actually see. Conceptually, it's so easy to picture, right? This invisible opposing force just warping the visible beams of light as they travel across the universe. It's a genuinely brilliant way to visualize the phenomenon. But, and this is a big but, the universe has a very strict rulebook. Which brings us to section 2, the rules of optics. So when we look at this reverse light idea through the actual unforgiving lens of physics, we run into some pretty fundamental conflicts. First off, light literally cannot bend light. Think about it. If you take two flashlights into a dark room and cross their beams, they just pass right through each other. No deflection at all. Second, gravity is the only true bender in this game. In a vacuum, light travels perfectly straight unless it hits a gravitational field, which is essentially warped spacetime, or unless it hits a change in an optical index, like when light passes through a piece of glass. And third, if dark matter truly was this opposite form of light, it wouldn't act like some smooth, invisible choreographer. In physics, opposites, like matter and antimatter, they generally just cancel each other out, or they interact incredibly violently. They definitely don't smoothly bend things around them. So yeah, this creates a massive direct clash between our elegant little concept and harsh physical reality. On one hand, we've got the beautiful idea of this invisible opposite light acting like a cosmic sequin to smoothly bend normal light. But on the other hand, the strict laws of electromagnetism dictate that these opposites would just cancel out entirely or react with immense explosive violence. Basically, if dark matter really was reverse light, the night sky wouldn't be filled with beautifully bent starlight. No, it would probably be a chaotic, terrifying mess of canceled light and violent energy interactions. Definitely not the smooth sparkle we're looking for. Let's pivot to section 3, the cosmic lens. But here is the crazy twist. While the mechanical physics of that opposite light idea completely clash with reality, the visual intuition, it is 100% spot on. Dark matter absolutely does bend normal light. In fact, it bends it so severely and so spectacularly that the exact visual effect you pictured, that beautiful sequin-like warping of the universe, is exactly what astronomers actually see when they look through their telescopes. The visual intuition was literally perfect. We just need to pop the hood and swap out the engine that's actually driving the effect. So, instead of reverse light, the true reality of what's happening here is called gravitational lensing. Dark matter is essentially acting exactly like a giant cosmic lens. Let's think back to those rules of optics for a second. Just like a thick glass magnifying lens slows down and bends light to a focal point because of its optical index, dark matter is doing the exact same thing to light beams that are traveling across the vastness of the universe. So it isn't some powerful form of magical light doing the bending, but the end result is a literal masterclass in cosmic optics. And understanding how this mechanism actually works is just incredibly satisfying. Picture this. Out there in deep space, we have the massive, invisible weight of all this dark matter. And because of the rules of gravity, that immense weight literally creates a physical dent in the fabric of space-time itself. It's almost like placing a heavy bowling ball on a trampoline. So, when ancient light from distant galaxies travels across the universe and encounters this massive dent, it just cannot go straight. The actual terrain of space is warped, and that forces the passing light to take a curved path around the dark matter. It is the ultimate cosmic optical illusion, and it's all caused by gravity. Moving on to section 4, what else is out there? So, where do we go from here? I mean, if dark matter condenses space-time so severely that it actually curves light, you have to wonder, what are the absolute limits of this? What if that initial spark of an idea, a universe filled with hidden opposing forces, is actually pointing us toward even stranger science? Well, scientists are actually pursuing some phenomenal frontiers right now based on these exact rules. First up, they're calculating just how warped this cosmic lens can get. They're testing the absolute maximum amount a gravitational field can bend light before the physics just totally break down. And from there, the search gets even weirder, and it actually directly echoes our original reverse light concept. Physicists are out there actively hunting for theoretical particles they call dark photons. Yes, dark photons. The idea that the dark sector might actually have its own completely hidden version of electromagnetism is a very real, very serious area of study. And hey, when you push that dent in spacetime to the absolute extreme, you get a black hole. A place where the dent is so deep that light doesn't just bend, it gets completely, hopelessly trapped by gravity, unable to escape at all. We started all this with the beautifully poetic idea of a sequin universe, and we discovered that gravity actually steps up to fulfill that visual promise perfectly. But with physicists now actively hunting for these dark photons, it raises a pretty thrilling possibility, doesn't it? If the dark sector truly has its own entirely hidden version of electromagnetism, what other invisible, totally unimaginable forces are out there, glittering right now in the vast spaces between the stars?